Hello, this is Dr. Amudapriya, Associate Professor Tripli, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control. In this lecture, we will be discussing about the methods of reactive power injection. So, a power system is said to be well designed if it gives a good quality and reliable supply. All the equipments on the power system are designed to operate satisfactorily only when the voltage levels on the system correspond to their rated voltage, or at most it should stay within 5% variation. If the voltage variation is more than a pre-specified value, then the performance of the equipment will be getting into damaged, or it will be malfunctioning, what is to say. So what we go for is, we go for the active power frequency control and the reactive power voltage control. So both the ways of control methods are being applied. So let us see what is voltage control. For example, a load is being connected to the source through a line. So let us consider this. Let V2 be the load side voltage and V1 be the source side voltage. So V2 is equal to V1 minus Qx by V1 minus Jpx by V1. This we are going to take the reactive power alone. So obviously this voltage is getting influenced, right? So let us consider certain voltage control methods. Shunt capacitor or reactor method, series capacitor method, synchronous capacitor method, tap changing transformer method, and booster transformer method. So what is a shunt capacitor or reactor method? They are used for lagging power factor circuits. Shunt capacitors are disposed along the routes to minimize the losses and voltage drops. On light loads, when the voltage is high, the capacitor output is large and the voltage tends to rise. The shunt reactors are being used for leading power factor circuits, as in lightly loaded cables. So location of the shunt capacitor is, it is located, it is used on the load end side, where a wide range of sizes can be replaced. The shunt reactor may be permanently connected to the line to limit the temporary overvoltage and switching transients. It may be connected in the EHV buses or to the tertiary winding for adjacent transformer. Let us consider about the next type, that is a series capacitor type. In this case, they are connected in series to a line conductor to compensate for inductive reactance of the line. This reduces the transfer reactance between the buses to which the line is connected and increases the maximum power that can be transferred and reduces the reactive power losses. The voltage drop, obviously we know due to resistance and the inductance and capacitance effect. When the capacitance is very high, then series resistor is very useful. This also will improve the maximum power transfer capability. So where it is being located? At the midpoint of the line terminals, or at the 1/3 or 1/4 points of the line. So the series capacitor are being applied to the distribution feeders, EHV transmission system, etc. These are some of the advantages and disadvantages of the series capacitors. And in case of synchronous capacitor or condenser, the synchronous motors running without the mechanical load can absorb or generate the reactive power depending on the excitation. As a synchronous motor losses are considerably compared to the static capacitors, the power factor is not equal to 0. So when used with the voltage regulator, the compensator can automatically run overexcited at times of high load and underexcited at times of light loads. The advantage is that its flexibility of operation can be applied for all load conditions. So it is more advantageous, but the cost of maintenance will be somewhat high and it may produce some noises. So let us move to the next type, that is a static VAR compensator system, that is HVC. HVCs are shunt connected static generators and absorbers whose outputs are varied so as to control the specific parameters of the electric power system. It has no moving or rotating components. Many different types are there: thyristor controlled reactor, thyristor controlled capacitor, thyristor switched reactor, thyristor controlled transformer, etc. While considering the tap changing transformer, the voltage control of a transmission and distribution system is obtained by tap changing transformers. Tap changing either on off load or on load condition. By changing the turns ratio of T by F, the secondary voltage is changed and thus voltage control is obtained. While considering the booster transformer, the two-winding load tap changing transformer performs two functions, transforming the voltage and boosting the voltage. So obviously this can be installed at the substation levels. An intermediate point in a line also the voltage where the voltage regulation is being needed. The point is identified and then implemented. Thank you.